One of the first rules you need to know about triangles: all angles in a triangle add to 180. If you don't already know that, learn it now. All angles in a triangle will add to 180 degrees, regardless of the side length. Okay? All angles, and I mean all. So it doesn't matter what the triangle is shaped like. If you have 3 different sized sides, the angles A, B and C will still add to 180 degrees, always. Okay? There are other notations, and I've already used some here. So these symbols here mean these 3 side lengths are different. If I drew a triangle that looked like that, okay, that means all 3 sides are the same because they have that same tick mark on them. Okay? Now if you know about triangles and all angles would add to 180, okay, and all the sides are the same, then that must mean all these angles are also the same. Okay, so if you come across what's called an equilateral triangle, okay, all sides are the same and all angles are the same. There are some more triangles you might need to know about, and one is called an isosceles triangle, okay, where these 2 sides here are the same, isosceles. Needed to think about that one. Isosceles triangle. These 2 sides here are the same, which means these 2 angles here are also the same. Alright, and you can come up with fancy right-angled ones, okay, where this and this side are the same, and that's 90. Now if all the angles in a triangle are up to 180, that means between this angle here and this angle here must be 90. If you split that in half, each of these angles is 45 degrees. Alright, so each of those angles is 45 degrees. Now, there's these things called complementary angles. Okay, and that's talking about at 90 degrees. Okay, they add to 90 degrees. Okay, for example, angle A and angle B will equal not 180, 90 degrees. Alright, there is another set of fancy angles that we call supplementary, and they add to 180 degrees. Okay, for example, A plus B will equal 180 degrees. If you have 2 lines crossing over, then these are what we can call vertically opposite angles. Okay, so I'm going to grab some different colours here. This angle here is exactly the same as that angle there, while this angle here is exactly the same as that angle there. And if you know anything about geometry, which I hope you already do, you will know a full circle is 360. So even if you know only one of these angles, if you know this one, you can work out this one because it's exactly the same, and then from there, using the 360 rule, you can work out what each of these is as well. So even if you're only given one angle in a system like this, you can work out all angles. Another fancy word, make that a little bit longer. Okay, so those 2 tick marks mean that these 2 lines are the same. Right, that means that it's perpendicular. Okay, so we start with perpendicular because it means at a right angle. Okay, and that symbol means it's a right angle. So what we need to do, these mean it's the same, and there's a fancy word there, bisector. Okay, splitting into 2. Okay, so this line here is a perpendicular bisector of this line here. Those symbols is what it means. Okay, this side is the same as this side, that's what those 2 tick marks mean, and this is a vertical at a right angle to the horizontal, so it's perpendicular, and since it splits it into 2 sections, that's what that word basically means. Okay, it's called a perpendicular bisector. If you have, similar to the first example, if you have two parallel lines and one line crossing through them, then we have a system where angles are the same. Alright, and I'm going to grab my different coloured pens again. We already know that these two are the same. Okay, but these two are also the same angle. Because those two lines are parallel, the angles must be the same. The same can be said for the red ones. They are the same angles. Okay, that's called alternate angles. Okay, so this angle is the same as this angle, or this angle is the same as this angle, okay, and these are the same as well. Alright, so similar to the vertically opposite angles up the top here, you can expand that out into a system where you have parallel lines. The other interesting thing you can do here is, if you think about it, and I'll grab another colour, that blue angle is 180, okay, so 180. So therefore, the green angle plus the red angle must equal 180, because the green angle there and the red angle there add together to 180. And it doesn't matter where you do that, you could do it out here. In here, that's a straight line, so that'll add to 180. So it doesn't matter where you do it, they will add to 180. This is perhaps one of the more difficult things to understand. If you have angle A, angle B, angle C, and angle D, okay, angle D is an exterior angle here, okay. The other thing I should note while we're doing it, angles are normally lowercase and points are normally uppercase. Okay, and you'll notice that little b corresponds with big B, and little a corresponds with big A, and little c corresponds with big C. So when you're labelling a point, okay, this is triangle ABC, but this is angle little a, okay? So we use lowercase. But this angle D out here, okay, and you guys are more than welcome to try this, is actually the same as A plus B. Now here's the tricky bit. Why? We know that angle A plus angle B plus angle C must equal 180. Okay, because they're in a triangle, so they have to equal 180. But we also know that C plus D must equal 180 because that's a straight line. So therefore, we know this must be equal to D. So therefore A plus B, so these two green angles here, must be the same as this one green angle here. So they must add to the same value. One more to cover. Okay, and this is to do with circles, so you're going to have to put up when we're drawing a very dodgy circle. Okay, close enough. If you go through the centre of that circle and draw a line from one side to the other, it doesn't matter what angle you draw this on, it has to be a straight line through. Okay, and then you draw a line up to the outer side of the circle. That angle at the outer side of the circle is always 90 degrees, always a right angle. You can test it if you'd like. I'll draw another one. This one's nowhere near as good as the other one, and I'll draw a different line. So I'll draw an angle out here, and I will take that to there this time, and I guarantee you that had I drawn my circle accurately, that would be 90 degrees. So the outer angle from a semicircle, so think of a semicircle here, okay, if you draw a triangle that goes from one edge to the other of a circle through the centre, out at the point here where you draw that triangle, that angle will always be 90 degrees.